Hello, I am one. Welcome to the third week of May in this shutdown series of distance learning. So today we're going to be talking about linear equations. The reason why we're doing this is because there was one thing that I wanted to leave you with this year, and that's a solid learning on linear equations. So if some of this seems like review, it is. If you haven't learned it, this is an opportunity to learn it now. So here we are, Math of Linear Equations, Part 1. Just as an overview, these are some of the topics that we'll be covering in this week. Here's part 1, and we're talking about the slope definition and formula. You guys know the slope of a line. The equation of a line in SlopeIntercept form, that's the answer to what is the equation of a line? Y equals mx plus b. And the equation of a line also in standard form, and creating standard form when given other forms. We're going to be graphing a line using the slope and y-intercept. We're going to be graphing a line using a point and a slope. We're going to be graphing a line using a table. And we're going to be graphing a line using 2 points. In linear equations part 2, we're going to be talking about writing the equation of a line when given 2 points. Write the equation of a line when given a slope and a y-intercept. Write the equation of a line parallel to a given line and passing through a given point. Write the equation of a line perpendicular to a given line and passing through a given point. Be able to find the point where two lines cross. Be able to determine if two lines show no solution. Be able to determine if two lines are the same line. So it starts off with this guy right here, the slope. And if you look at the picture in the upper right-hand corner, we're looking at a boat ramp. And notice here that they're saying that it rises 2 meters when it's going horizontally 5 meters. The slope of a ramp describes its steepness, and for the ramp at the right, we're talking about a rise over run. Since it rises 2 meters over a run of 5 meters, then that makes the slope 2 over 5. If you look over to the left here, we're looking at a line that's on a graph, and there's 2 points that are identified on that line. Notice what we're doing here. We're taking the y values where we're saying 7 minus 4 and getting 3 units. So we're taking the difference of the y's and putting it over the difference of the x's. And so we've got 5 minus 3, and that becomes 2. So this slope of this line that you see on the graph has a rise of 3 over 2. Now, if you're calculating a slope, here's the formula for calculating the slope of a line. So you might remember that it's the difference of the y's, and it's expressed as y2 minus y1 divided by x2 minus x1. And make sure that you keep it in that order when you're given those 2 points. That don't do y2 minus y1 over x1 minus x2, or don't come up with any other variations. This is the way you find the slope of a line, and that the formula for it is it's just simply y2 minus y1 divided by x2 minus x1. So here's example 1. We're ready to find that. Find the slope of a line that's passing through negative 2, 2, and 3, 4. Well, let's find where negative 2, 2 is. Negative 2, 2 means we're going to be going to the left 2 and up 2. So there's negative 2, 2. And let's find where 3, 4 is. Well, it's just to the right of 2 and up 4. And so here we are right here. So we're looking for the slope of this line right here. And if you look carefully, and know that the slope formula is what it is. So the slope formula is going to be m equals y2 minus y1 over x2 minus x1. Let's make the first set the x1, y1, and the second set x2, y2. So we got y2, which is 4, minus y1, which is 2, and that divided by x2, which is 3, minus x1, which is negative 2. Okay, now we just have to do our math, right? 4 minus 2, that's 2. 3 minus negative 2, well, that's plus 2, so that's 5. And so the slope of that line right there is 2 over 5. And you'll notice that you could actually even count on it and say, if I start at this point right here, that I can count up 1, 2, and go over 5. 1, 2, 3, 4, 5, and we end up with another point on that line. Okay, here's example 2. Find the slope of the line passing through 0, 0, and 3, negative 3. Well, let's go ahead and graph and see what that looks like. We're talking about from here, and we're going to the right 3 and down 3. 1, 2, 3. And we have that right there. So our line that we're trying to find the slope of looks like this. And so we're trying to find the slope of that line. Well, once again, let's use the slope formula. The slope formula is going to be y2, which is going to be negative 3, minus 0, and that over x2, which is 3, minus 0. And that's going to be our slope, so we'll just write that as the slope formula. Well, negative 3 minus 0 is negative 3, and 3 minus 0 is 3. And negative 3 over 3 does reduce because 3 over 3 is equal to 1. So our answer is the slope is equal to negative 1. And you'll notice that that's consistent with the graph that we have over there, because if we start on any point on there and go down one and over one, we're back to the line. Go down one again and over one, and we're back to the line. And so that's showing a slope of -1. Here in example 3, there's a couple of special cases here, and this is how it goes. Let's start off by just putting the points in. We have -1, which is to the left 1, and up 2, and that gives us a point that looks like that right there. And the second point is 3, 2, so it means we're going to go to the right 3 and up 2, and that gives us a point right there. Now if we draw the line that contains those 2 points, we end up with a horizontal line. Interesting. Well, let's take a look and see what the slope ends up being that way if we calculate it. You see, if we take y2, which is 2, and subtract y1, which is 2, and this is our slope formula, remember? And we're going to take that and take x2, which is 3, and subtract -1. I want you to see that on top we got 2 minus 2. Well, that's 0. And we've got 3 minus -1. 3 minus -1, that's plus 1. So that's 3 plus 1 is 4. We have a slope of 0 over 4. Well, that just means we have a slope of 0. Now, understand what this says. This has a slope. Don't say because you've got a slope of 0 that you don't have a slope. You do have a slope. The slope is 0. And what it means is that I'm rising 0 over a run of anything you want it to be. In this case, it says over a run of 4, I only rose 0. But I could run 100 and still rise only 0. So that's a slope of 0. And so don't say it's no slope. This is a slope of 0. Okay, in this next situation here, let's take a look at the points for this one. This one has 2 points, 2, 4, so it means that we're going to go to the right 2 and up 4, and there's a point right there. And in the other one, we've got another point, 2, 1, so it means we go to the right 2 and up 1, and that gives us a point there like that. Well, when we graph the line for this, it looks like this. That is a vertical line. And if we calculate its slope now, we take y2, which is 1, and subtract 4, and put that over x2, which is 2, minus x1, which is 2. Well, now look at what we have. This becomes -3 divided by 0. Now, we can't divide by 0. That's where we have nothing at all. So this is called no slope. So I want you to understand that a vertical line has no slope. And that's different from having a 0 slope, because if you have a 0 slope, you have a slope. It's just 0. But in a vertical line, you have no slope at all. So moving on to the next topic, we're going to be talking about the slope-intercept form. You recall that in class, I would always say, what is the equation of a line? And you would respond, y equals mx plus b. Well, that's something that hasn't changed. The linear equation, y equals mx plus b, is written in slope-intercept form. And the slope of the line is represented by the number that is in front of x, and that's m. So if you're looking at this equation that you see in front of you here, we have y is equal to 2x plus 3. The slope, m, is 2. The slope is not 2x. The slope is just the number 2. And the y-intercept, which is b, is 3. b equals 3. So the slope is 2, and the y-intercept is 3. Now here's what that means. If you look at this line right here, we're talking about, we could look at this point right here, and we can go the slope of 2, which means I can go up 1, 2, and over 1. That means I went a rise of 2 over a run of 1. 2 over 1 is 2. And notice too that the intercept is going through 1, 2, 3. So that means that b is equal to 3. In the next slide, we have example 4, which has 4 equations that we want to actually rewrite in slope-intercept form. So we're going to take the first one, and actually the slope-intercept form is exactly as you see it, but we're going to write it this way. Y equals -1x plus 2, because that negative sign really means -1, and that tells me that the slope then, m, is equal to -1. And that the y-intercept, well, that's b, and it's equal to 2. Okay, so for this next one, I want you to understand that this is a fraction that can be rewritten this way. Y is equal to 1/2 x plus 3 over 2. Now, so that identifies the slope then as the number that's in front of x. That's 1/2. And the y-intercept then, b, is 3 over 2. Okay, the next one, I want you to see it this way. Y is equal to, and notice there's no x there, so we're going to put a 0 in front of x. And then we're going to say -4. Now we can see clearly, oh, This has a slope of 0, so the slope is 0. And the y-intercept then is b equals -4. So we have a slope of 0 there. Okay, this next one is going to take a little bit of work. So we're going to bring it down here, and we're going to say 2x minus 4y is equal to 16. We want the y all by itself, and I want it to the left, so I'm going to subtract 2x from both sides. And when I do that, I get -4y is equal to -2x plus 16. And I'm going to divide everything now by -4, and I get y by itself now. Now, -2 over -4, that's 1/2. So this is 1/2 x. And positive 16 over -4, that's a -4. And so we have then an equation of y equals 1/2 x minus 4. That means that my slope, m, equals, it's the number in front of the x, 1/2. And my y-intercept now is b equals -4. And so there we have example 4. These are the equations in slope-intercept form. Let's look at example 5 here, graph using the slope-intercept. Well, we have to turn it into slope-intercept in this case first. So here's how this one goes. This one we have to subtract 3x from both sides. And so when we do that, y is now by itself on the left. We have equals -3x plus 2. This means that the slope is -3. We may as well call that 3 over 1 because that's what it really is. And then we can also say that b is 2. Okay, so now let's get on to graphing. So the graphing is going to look like this. B is equal to 2, so I'm going to put a point at 2. And I'm going to use the slope of -3 over 1. So that means I'm going to go down 3, 1, 2, 3, and over to the right 1. So that puts me right there. And I'm going to graph the line now. So we've graphed this line by showing a slope of -3 over 1 and crossing at the point y equals 2. This next topic is called the standard form of a linear equation. So here's the things that I want you to understand about this, is that we're talking about the standard form specifically looks like this. ax plus by is equal to c. Now, the A, B, and C, they're all capital letters, and I want you to understand that in order to be in standard form, those letters, A, B, and C, must be integers, meaning they're whole numbers that are negative, or they're positive, or they are 0. So let's just take a look at each one of these cases right here. In this case, A is -2, B is 5, and C is -15. In the next one, in the next equation, look at what we have here. A is +2, B is 1, C is -5. So there's a couple of different cases there of lines. Now here's another case right here. What I want you to see here is that this is actually saying x times 0 plus y is equal to 3. So here's, when you see it this way now, A is equal to 0, B is equal to 1, and C is 3. Similarly, in this next one, we have x, which means A is 1, plus 0 times y, which means B is equal to 0, is equal to -3. And so look at what we have here then. We started out with x equals -3, but we have A is equal to 1, B is equal to 0, and C is equal to -3. So let's take a look here at example 6. This one says, write y equals 2 over 5x minus 3 in standard form with integer coefficients. Well, we want integer coefficients, and one thing that we notice here, this is, first of all, it's in slope-intercept form, and we want to turn it into standard form. So we're looking for it to look like this: ax plus by is equal to c, and it doesn't look anything like that right now, so we have to make some modifications here. First of all, 2 over 5 is a fraction. It's not an integer. We have to turn it into an integer. And we can turn any fraction into an integer by just simply multiplying it by its denominator. So it's going to look like this now. Y is equal to 2 over 5 x minus 3. And in order to flatten out that fraction, we're going to multiply all terms by 5. And when we do that, y times 5 becomes 5y. 5's cancel for the 2/5, and that just turns that into 2, and we end up with 2x. Minus 3 times 5, 15. Okay, so let's subtract the 2x. And now we have -2x plus 5y is equal to -15. And you'll notice that that's in standard form because A is -2, B is 5, and C is negative 15. Let's take a look at this next one, of the line passing through negative 4, 3, and having a slope of negative 2. Well, that means we could write this in slope-intercept form, couldn't we? We could write y equals mx plus b. And we know what m is. It says that the slope is negative 2, so m is negative 2. And so we can rewrite this again. Y equals negative 2x plus b. Okay, we have the equation of a line in slope-intercept form. And so now we're also going to use the fact that we have this point, negative 4, 3, which means that the x value, the x coordinate, is equal to negative 4 when the y coordinate is 3. That means I can actually take this expression and write that y is 3 when x is negative 4. So that gives me 3 is equal to negative 2, which is my slope, times negative 4, which is the x coordinate, plus b. Now look at that, everything's numbers, and we can solve for b. So we have negative 2 times negative 4, negative times negative is a positive, that's 8, plus b is equal to 3. Let's bring this up here. 3 is equal to 8 plus b. And we're going to subtract 8 from both sides. I've got 3 minus 8, that's negative 5. And that's equal to b. So I can rewrite y equals negative 2x minus 5. Now we're not done yet because we still have to turn this into standard form. Well, that's going to take adding 2x to both sides. So if I add 2x, I get 2x on the left plus y is equal to, and what's left on the right? Negative 5. And now it's in standard form, and that's what we were looking for. 2x plus y is equal to negative 5. Here now, we're in example 7, where it says, find the value of y so that the line passing through the points negative 2, 1 and 4, y has a slope of 2 over 3. Well, let's identify some things that we know that's given from what they're describing. We see the point negative 2, 1. That's a nice thing. We can actually plot that. So let's go to the left 2 and up 1. There it is right there. And we also know that there's a slope of 2 over 3. So that means that we could actually apply the slope by going a rise of 2, 1, 2, and over 3, 1, 2, 3. And there's a point that is on our line. Well, we could go ahead and even graph that line if we want to. And it just gives us something to see as we're working the rest of the problem. Now, we know that the slope is 2 over 3, so we can just go ahead and say m is equal to 2 over 3, because m represents the slope. And we can also write y equals mx plus b. Y equals mx plus b. And then we can replace the m, because we know what it is. It's 2 over 3. Y equals 2 over 3x plus b. We're looking for a value of y so that 4 comma y is completed. And that means going over to 4 and then going up and saying, what's the y value of this point right here? We're going to save that for later, but let's just keep going here, okay? We need to solve for y equals 2/3 x plus b. And we have a point that we know for sure is on this graph. It's when x is equal to negative 2 and y is equal to 1. That's the point, negative 2, 1. So I can plug those pieces in. 1 is equal to 2 over 3 times negative 2 plus b. And now look at that. We've got enough information to actually solve for b. See, that negative 2 is negative 2 over 1, and multiplication of fractions is just multiply the tops and multiply the bottoms. So we have negative 2 times negative 2 is negative 4, and 3 times 1 is 3. And that's plus b, and on the left-hand side we haven't changed anything, and that's still equal to 1. Now we're going to add 4/3 to both sides. And when we do that, I'm going to just take this up to the top. I have now 1 plus 4 over 3, and negative 4/3 plus 4/3 is 0, so we can just say equals b. Well, 1 can be rewritten as 1 over 1 plus 4 over 3, and we need to change the denominators to all be the same, so that's going to be easily done by multiplying top and bottom of 1 over 1 by 3. So there we go, 3 times 1 over 3 times 1. 3 plus 4 now is 7, and we're over 3. So b is equal to 7 over 3. That means now I can rewrite this equation and call it y equals 2/3 x plus 7/3. So now we're trying to figure out what is the value of y when x is 4, because remember we were asking for 4 comma y. Now we have enough information to actually solve this, because watch what we can do. We could say y, which we don't know, is equal to 2/3 times 4 plus 7 over 3. Well, that's going to be 4 over 1 times 2. That's going to be 8 thirds plus 7 thirds. And I'm going to finish this off on top. Y now equals 8 plus 7, that's 15, over 3. Oh, hey, y is equal to, because 15 and 3 have a common factor of 3, so that just turns that into 5, because I can divide out a 3 from the top and bottom. And there we have it. That's the value of y. We were asking for what is y, and we're at a height of 5. Well, there's 5 right there. And we're showing that that's the answer to our problem. Y equals 5. Example 8 says, use a table of values to graph the equation y plus 2 is equal to 3x. Well, y plus 2 is equal to 3x kind of is all over the place and doesn't have a specific form. So I think I want to turn it into slope-intercept form. That's easily done by just taking y plus 2 equals 3x, and I'm going to subtract 2 from both sides. And I get y is equal to 3x minus 2. Now, the reason why that's so nice is because we can identify the slope. The slope is 3. We also know that b is equal to negative 2, which means we know the y-intercept, which is 0, comma, negative 2. So we can go ahead and put that point on our graph, negative 2. Now what we want to do is create a table of values. So let's go ahead and put x and y and make that the title parts of a table of values. And we're going to just give some points for x and solve for the points of y when x is that particular value. You can already see that if x is equal to 0, that y is equal to negative 2, because y is equal to 3 times 0 minus 2, and that becomes y is equal to negative 2. So that's why we get negative 2 for y, and that's why that point is already on that graph. Well, let's go ahead and go over to negative 2, and let's say y is equal to 3 times negative 2 minus 2. So that becomes y is equal to negative 6 minus 2. That's negative 8. So y is equal to negative 8. Let's also come up with another point, x equal 1. So now we're going y equals 3 times 1 minus 2. 3 times 1 is 3, minus 2 is 1. Y equals 1. So when x is equal to 1, y is equal to 1. Let's come up with one more. Let's let x be 2. So y equals 3 times 2 minus 2. 3 times 2, that's 6. Minus 2, that makes it 4. So y is equal to 4 when x is equal to 2. Well, that's a few points, and so let's go ahead and plot those. We already have 0, negative 2 plotted. Let's go to negative 2, which means we go to the left 2 and then down 8. Well, that puts us right here. And then let's go over to x is equal to 1. And we know that we go up 1, and that gives us this point right here. And one more. Let's go to the right 2 and up 4. That puts us right there. And now we have plenty of points to plot our graph. And so here is the graph of the line y plus 2 is equal to 3x. And so that takes us to homework. Homework is a worksheet, HW9A, and is in your Google Classroom. If you can print, please, a copy of it, then do that and show the work for each problem. Or if you can't print it, just put it up on your screen and pull out a piece of notepaper and do the very best you can of showing your work and carefully making graphs on your notepaper. Take a picture of that and turn it in, and that will be your homework. All right, thanks a lot. We'll talk to you later.